Okay, folks, flame on for you Fantastic Four fans. Okay, so we talked about the issue of the burner head, right? We said that in the machine we get this burner head, and this burner head is going to create a flame, and I want to look at this flame. Okay, I don't need to be afraid of it. I need to look at the flame to make sure that I see this nice, clean blue area down here at the bottom of the flame, all the way across, that doesn't have anything in its way because that's where the majority of the sample measurements are going to be made. In the previous video, I told you there were two different types of burner heads. There was an acetylene burner head, and then I told you there was a nitrous burner head. So let's start with acetylene first. Acetylene is the most common type of gas that you will use in atomic absorption spectroscopy. So acetylene, the problem is that it is explosive. Well, we're using it for a flame. It should be. So you really have to take care when you utilize the acetylene tank. You want to make sure that it's turned off when not in use and turned on, of course, when you do use it. So when you leave for the day, do not forget to turn off the tank. What happens is that this tank could be sitting over to the side of the machine. And this tank has a line that basically will come from the tank into the back of the instrument. And that line is filled with acetylene. So if you do not turn this tank off, if there is a leak in the line, then you're going to get acetylene that begins to fill up the room. And any little spark that you're going to have will cause this to go boom! And you don't want that to happen, right? So when you're not using the AA instrument, turn off the acetylene tank. Don't be blowing up our lab, and you'll be okay. All right, the structure for acetylene. Well, if we look at acetylene, that is a two-carbon chain, and that's connected by three bonds. So these two carbons, well, they're pretty lock and key. They're holding hands quite a bit, and they're attached at the hip. And on this side, we have a hydrogen to make up the fourth bond. And on this side, we have a hydrogen to make up the fourth bond. All right, so this is the structure for acetylene. The chemical name is not acetylene. The chemical name is ethine with a YNE ending. A little caveat here. The YNE ending is the ending that we use when a molecule has a triple bond. So that's why we call it ethine. However, the ENE ending is a misnomer here because that's the ending that we use when we describe a double bond. So a lot of people think that acetylene has two carbons that's connected by two bonds, not by three. And the reason is because they're thrown off with the ENE ending. It's just a common name that we use and it confuses people, and I'm sorry that it does, but this is just the accepted name that was given to the gas back in the day. So that's one type of tank that we have on the AA instrument. The acetylene gas will create temperatures for us that's in the 2600 K range, and that's 2600 Kelvin. Okay, 2600 Kelvin, how hot is that? Well, you know that water boils at 100 degrees Celsius. If I wanted to convert that over to Kelvin, I would add 273. So at 373 Kelvin, that is when water boils. So if water is boiling at 373 K, now you have a comparison on how hot 2600 K is going to be. So I would tell you, do not put your fingers in the flame. Do not try to roast marshmallows in the flame. Do not try to make s'mores in the flame because this is typically hotter than your average kind of bonfire that you would see out in the field in the middle of nowhere. Okay? So 2600K is pretty hot. The problem is that 2600K might not be hot enough. And the reason is because of the metals that I'm trying to analyze with the instrument. Some of the metals, majority of them, are okay with 2600K. But some of the metals need to be a little bit hotter. And that is the purpose of the nitrous oxide. So the nitrous flame over here, that is N2O. Some people call this laughing gas. It's the same stuff. Go suck on a laughing gas tank, and it's like going and having a pleasant trip at the dentist. Okay, so that N2O tank is probably going to be a little bit smaller because we don't need to use it that much. The N2O tank creates a hotter flame that we need for the AA sometimes. And that tank can go all the way to 3100 Kelvin. So we're looking at a 500 Kelvin increase here. And sometimes stubborn metals require a hotter flame to do what they should do in an instrument. So that's why we have two burner heads. One burner head for the acetylene and one burner head for the nitrous. And again, the reason is because temperature is very important. You can't measure a metal if it's not going to freely go into the flame to get measured. And the hotter flame will allow some of the stubborn metals to be detected and analyzed in the instrument. All right, so that's the story with two different burner heads. You got to make sure that they match the proper gas that you're using in the analysis. And the flow rate for both of these should kind of be the same as far as the sample is concerned. So if I'm using the acetylene method, about 10 mils a minute is typically what I want for the sample. And then if I'm using the nitrous method, it's typically 10 mils a minute for that one as well. So the flow rate of the sample does not change, even though I'm using two different gases. Okay? All right, so in the next video, we'll continue on this discussion of the flame now that we know there's two different gases that can make my flame and why there's two different gases to make the flame. And we'll go through and we'll talk about some of the other minute details that you would need to know when setting up this machine and getting ready to analyze a sample.